All right, let's look at how when we look at how the electrons are arranged in an orbital diagram. We can try to use that information to predict what kind of ion an element or an atom might form depending on its electron configuration. And these are two of the noble gases, neon and argon. Neon has 10 electrons, it's element number 10. And if you look at its orbital diagram, it has a filled energy level 2, so it has 8 electrons in its outer highest energy level, so it's completely full, which is a stable configuration. Atoms want to have that highest energy level filled. If we go to the next noble gas, argon, which has 18 electrons, then its energy level 3 is filled with 8 electrons of the 18, and so its valence shell has a full 8 electrons in it. And, you know, it's one of the reasons that noble gases are so unreactive is they don't want to give up or take in electrons. They don't want to share electrons because their outer shell is full. So let's look at how to use that information to predict what kind of ions an atom will form. Right. So if, for example, we have sodium atom and, you know, it has 11 electrons because it's element number 11, and we draw the orbital diagram to fill the 11 electrons that we have. We have a 1s, a 2s, a 2p, and a 3s, and the 11 electrons are going to go into the lowest levels first, and they're going to be opposite spin. So we have enough electrons to go out and put one in our 3s, right? And so right, these are our core electrons, and what we have is one valence electron. So we have one electron that's in that highest energy level by itself. Right? And if sodium atom wants to fill that outer shell, either it needs to completely fill its S and P, so it has to go out and get 7 more electrons. Or the other way to have a full outer shell is to give up this electron, and then it has the same configuration as neon. Right, and so it's going to be easier for it to lose 1 electron rather than to gain 7. So from this, we would predict that sodium will lose this electron, right? And if sodium loses an electron, it has a plus charge because now it has 11 protons and 10 electrons. And so then its electron configuration one s, 2s, 2p, and we've lost that electron in our 3s, right? Our 3s orbital is still out there, but now it's empty. And so by sodium becoming a +1 cation, now it has the same electronic configuration as the preceding noble gas. So instead of trying to get the electron configuration of the next noble gas, argon, it ends up getting the configuration of the preceding noble gas. And that's what happens when we have a cation, right? We're losing electrons, so we get a positive charge. So our electron configuration will move back towards the previous noble gas in the periodic table. So let's look at what happens if we have a chlorine as our element, right? And chlorine is element number 17. So we're going to have 17 electrons. So we're going to need a little more space to put all those electrons. Be a little sloppy with my box drawing here. Right, and so we have a 12. We have a 1s, a 2s, a 2p, a 3s, and a 3p, so we'll need that space to put our 17 electrons. So we start from our lowest energy level and then fill them from there. All right, and that gives us 2, 4, 6, 8, 10, 12, so we still have 5 more electrons to put out. So each degenerate level gets 1 first, and then we have 1, 2 there, and that's our 17 electrons, right? And so we did do this very well, but if we draw a line here, these are our core electrons. Our highest energy level is 3, and those are our valence electrons. So we have 7 valence electrons. So to have a full outer shell, either chlorine is going to lose these 7 electrons, and then it'll have the same configuration as neon, or else it needs 1 more electron, and then it has the same configuration of argon. So it's going to be easier energetically to gain an electron rather than to lose 7. So chlorine will gain an electron, and it'll have a negative charge. It becomes an anion. And so if it gains an electron, now it has 18 electrons that we have to fill out. So we need the same orbitals we had before. But now we have 18 electrons, so that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right, and so the chlorine ion, which since it's a negative charge, we call it an anion, has 18 electrons because from the neutral atom, it gained 1 electron, so it had 17, it gained when it had 18. That 18th one goes into that partially filled 3p orbital, and now it has the same electronic configuration as argon, so it's happy because its outer shell is now full. So when we become an anion, we gain electrons to move to the electron configuration of the next noble gas in the periodic table. And that's how you would predict if something's going to be a cation or an anion, and determine what its charge will likely be is based on its orbital diagram and trying to fill that outer shell.